Now in this question we are going to get into actually calculating mean, standard deviation, and finding the median as well. The mean and the standard deviation go together, and before I get too far I'm going to walk through the calculation of the standard deviation, which is quite involved, but having said that, you'll see in the future problems I will use the calculator to actually do all that tedious work for us, because it's very easy, as you'll see, to make a simple mistake and then everything is off. So I'll also use the calculator on this one. There's a link to it in the course itself. You can use any calculator you'd like. TI-84 has a built-in application for finding the statistical mean and standard deviation just by entering in the data. Take a look at that. It's in the back part of the chapter. So first, for the mean, what we're going to need to do is take the data, add it all together. So I'm going to start listing it down here vertically. 15.2, 18.8, 19.3, 19.7, 20.2, 21.8, 22.1, and 29.4. So it was nice that they put it all in order for us. To find the mean, we will add all of these together and we'll get 166.5. It actually took me 2 times to do that because I think I left off a number or something. So you have to check yourself. There are 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So to get the mean, we will then divide this by 8. And when we do that, we get 20.81 as our mean. So that's the answer to the A part. What we do next, we'll find the median. I guess we should go in order. I don't know why, but the median is, now that it's in order, or was given to us in order, we're trying to find the piece in the middle. So we come, here's 2 pieces, 2 pieces, 2 pieces, 2. Here's the middle right here, halfway between 19.7 and 20.2. So to get the median, you've got to come up here. The mean is 20.81, and B, the median. We take those 2 middle numbers, which is 19.7, add it to 20.2. Let's put a parenthesis around it because we want that done first, and then we divide by 2. One of the mistakes I see often is you don't put the percentage, parentheses, you divide by 2, and that really only affects the 20, so your values are off. This gives us 19.95. And again, we should always have units. These are in seconds with this particular problem. Now let's continue with the C part, which is finding the standard deviation. What we're going to do is take each of the data pieces, subtract the mean from it. So you'll see how tedious this becomes. But it's good to go through it once in your life and help you understand that what it is you're finding the deviation from the mean, how far from the mean each of these points are. And then we're going to do a little manipulation because we're going to see that this really gives us something that isn't useful to us. Okay, so we'll do each of these. This gives us a negative 5.61. This gives us a negative 2.01. This one gives us negative 1.51. Here we get negative 1.11. Here we get negative 0.61. This one is 0.99 into the positive region now, and 1.29, and finally 8.59. Now here's the thing, if we add all these up, generally we'll get 0. We've got a little bit of a rounding error, so we get 0.02, but that's due to actually not going all the decimal places out there. So these are the deviations, but they're not really helpful. So what we do next is we're going to square each of these. And just to save us room, I'm going just to take our work that we have. We come back and we're going to square each of these deviations to the second power. And if you're asking why, that's at this point sort of the wrong question. It gets us to what we want, but it is a manipulation, because when we square it, we'll get positive numbers. When you add positive numbers, you're guaranteed to have something different. What we will then do is find that average, take the square root to unsquare things, and then we've got what we call the standard deviation. Okay, so let's do this. We square each of these. This one gives us 31.47. Again, I had to do this calculation at least twice to get to the right answer. The third time I did it to check myself. And that's why we're going to highly recommend that you use a calculator to do the calculations. This one gives us 0.37. This one gives us 0.98. Let's see, where are we? 1, 2, 3, 4, 5, 6. This one gives us 1.66. And this one gives us 73.79. Okay, we add all of these together and we get 115.82. In this case, to find its average with the standard deviation, we divide by 1 less than the number we have. So we have 8, we're going to divide by 7. Again, you're going, why? Because the people who did this found that that gave us more accuracy when we had a smaller number of data pieces. And basically the break-off rule is about 30, or when we're dealing with a sample, we always divide by 1 less than the number of data pieces. So we're going to divide by 8 minus 1, which is 7. And we're going to get the value 16.55. Kind of running out of room here. So I'm going to put this over here. This is what we call the variance, and you're going to see when I bring up the calculator version. This is the variance, and to find the standard deviation, abbreviated SD, I take the square root, 16.55, and what do we get is 4.068 as our standard deviation final. And again, here's a picture of what it looks like putting it into the calculator. I put in each piece of data, I click on calculate, and it finds the mean, the median, and the standard deviation for us. And as we're going to use this same tool later on, it also gives us something called the 5-number summary and a lot of other valuable data or valuable information that we can use in analyzing the data.